So in the last example, we just saw why you have to go back and check your solutions, because sometimes the solution you get is not going to work, and that is called an extraneous solution. So an extraneous solution is a solution that gives you a false statement when you go back and plug into the original equation.
We need a puppet show, Mom. You need a puppet show?
Okay, so let's look at two more examples. So example 3. So 3, and then in parentheses, x plus 1 raised to the 2/3 equal to 12. Now in this example, notice how we have a rational exponent, but as you should know how to do, you should how to now go from exponential to radical. So before I do anything, just like I've been doing, I always want to either isolate the radical, or in this situation, I want to isolate the factor. So I've got this 3 that's in front of this that's in the way, and I need to move it. So 3 times this quantity. So to undo multiplication, I'm going to use division. So I'm going to divide both sides by 3. And so I have x plus 1 to the 2/3 is equal to 4. Now, when it comes to rational exponents, I prefer looking at them in radical form. So I'm now going to turn this into a radical.
Okay.
So 2/3 is the same thing as saying x plus 1 squared. So 2, Jacob, and then it's the cube root. So the cube root of x plus 1 quantity squared. Again, you gotta pardon my kids. And that's equal to 4. Okay, so because we're taking the cube root, to undo the cube root, we have to cube each side. Okay, so first step, get rid of radical. So now the radical's gone, leaving me with x plus 1 quantity squared is equal to, so 4 to the 3rd power is 64. Now, I don't have to worry about expanding this one out because it's a quantity being squared, and to undo a square, in this case, we can use our square root method. So I'm going to square root both sides to get rid of the square. But because I'm square rooting both sides to get rid of the square, I have to take into consideration that there's 2 possible solutions. So the square root of 64 is 8. And then you could have positive 8 or you could have negative 8. So x could be 2 solutions. X plus 1 could be positive 8, or x plus 1 could be negative 8. So if I subtract the 1 from the 8, x could be 7, or x could be negative 9. Now, like we saw earlier, I have to check both solutions. I've got to make sure that both of these work or one of these works, or maybe none of them could work. So I gotta check. So the first one I'm gonna check is x is equal to 7. The second one that I'm gonna check is x is equal to negative 9. So I'm gonna go back up to my original equation. I'm gonna replace the x with the 7. Okay, I'm going to go ahead and set it up on both sides. Shh. Boys.
And I don't like it because I'm reading.
Mommy's recording a lesson.
And I'm reading.
Okay, so 3 then times 8 to the 2/3. Is that equal to 12? All right, so 3, 8 to the 2/3 is the cube root of 8 squared. And if you type that into your calculator, the cube root of 8 squared is 4. So 3 times 4 is indeed 12. So x equal to 7 checks out. So now let's try it for negative 9. So negative 9 plus 1 is negative 8. And so I'm going to turn this one into a radical now. So 3, the cube root of negative 8 squared. Oops. Okay, so I'm going to go ahead and break down negative 8. Because it's negative 8, that breaks down to negative 2 times negative 2 times negative 2. And since I've got 2 sets of those underneath there, I mean, I can go ahead and write them out again. 2 negative 2's comes out of the radical because I'm taking out groups of 3. And so then I'm going to times that by the 3 to start with. So 3 times negative 2 is negative 6. Negative 6 times negative 2 is positive 12. So negative 9 is also a solution. Now, if you're not sure and you don't believe me and you don't understand where that comes from, plug it into your calculator. Type in negative 8 to the 2/3 to double check that that's going to give you a value of 4. Okay? So, in this situation, this one has 2 solutions, 7 and negative 9. So I'm going to stop this video. You've got one more example to look at. Go back and rewatch this. Again, if you're not sure, always go back and plug in. But this one had 2 solutions. Make sure you watch the next video for the 4th example.